Hey there, fellow coders. Sorting algorithms are like the rock stars of computer science. Get ready for a journey where we'll explore and code the top 10 sorting algorithms in 3 different languages: JavaScript, Python, and C++. On number 1, we have bubble sort. Alright, so let's kick things off with the classic bubble sort. Bubble sort is simple, intuitive, but not always the most efficient. Imagine sorting a deck of cards by repeatedly swapping adjacent cards until they're all in order. Let me show you how it works in JavaScript. Alright, so as you can see on my screen, we're going to use this fs module for the file handling, as well as we're going to generate some random numbers, 10,000 entries of 5-digit random numbers using the math.random function. Afterwards, we'll perform this functionality, the bubble sort function. This will swap the adjacent entries with each other, comparing on the basis of whether the numbers are in the right order or not. And then we're calling this getRandom 5-digit number function, storing the list of random digits into the random numbers array. Now we'll use this random numbers array and write it into our input file right here. Once the input file is ready, we will display input file created with 10,000 random 5-digit entries on the console. Afterwards, we'll call the bubble sort function that we created above right here. And this date method is used because we want to calculate the execution time of the algorithm. So once this is done, now we need to write the sorted output into a file. For that, we will again use the fs module and we will write the sorted array into the bubblesort.txt. Once this is done, we will display the execution time on the console and print the message sorting completed. So that's it, and that's bubble sort for you. Now let's go and run this code as well as the Python version and the C++ version parallelly and check which one performs the best. As you can see, the execution time for JavaScript is 939 milliseconds. As for Python, it is 4570 milliseconds. And as for C++, it is 194 milliseconds. As you can see, it has generated the input file as well as the sorted file. As you can see in the input file, it has exactly 10,000 entries of 5-digit numbers, which are randomly sorted in disorganized manner. And in the sorted file of the bubblesort.txt, you can see that all the entries are sorted in ascending order. Bubble sort has its own strengths and weakness. The strength of bubble sort is that it is simple and easy to implement, but the time complexity for bubble sort is O(n) squared, which makes it really not efficient for large and real-world applications. So that's it for bubble sort. Moving on to selection sort, a straightforward algorithm where we repeatedly select the smallest or the largest and place it in its final position. This one's like finding the minimum or maximum in an unsorted list and building your sorted list from there. So let's go and check it out in code. Alright, so most of the code is similar to the code we previously viewed. So let's discuss the part which is different. That is the function selection sort. We're going to use 2 loops, the same as bubble sort, but this time we're going to use 2 pointers. The first one will point to the starting value of the list, and the second pointer is going to iterate throughout the list. Now, the condition on which it's going to swap the value is whether the iterating pointer gets a value which is less than the starting item. Then it will swap the values of both pointers, and this is how selection sort is performed. Next, as you can see, we're doing the same thing as we did in the bubble sort. We're going to call the getRandom 5-digit function here and assign it to an array random numbers. Then we're going to create the input file, and once the input file is created, we're going to print out a message on the console. Afterwards, we'll call the selection sort function and we will calculate the execution time for it. Once the function is called and the sorting is done, we will write the output in the file using the same fs module. And once the output is written to the file, we will display execution time on the console. Alright, so once this is done, we're going to execute all 3 versions of code from JavaScript, Python, and C++ parallelly and check which one performs the best in execution time. So let's go and do that. As you can see, for JavaScript, it took only 80 milliseconds to execute this algorithm. As for Python, it is around 3,966 milliseconds. And the C++ code took 210 milliseconds of execution time. Alright, so let's go and check the output now. As you can see, it has generated the input file with a 10,000 entries of 5-digit number, and as well as it has generated the selection sort.txt with the sorted output. So that's it for selection sort. On number 3, we have insertion sort. Now, picture sorting ahead of cards by repeatedly taking a card and inserting it into its proper place in the sorted portion of the head. It's like building a sorted list one element at a time. Let's look at the code and try to understand it. Same as the earlier discussed algorithms, it also uses nested looping, but this time the starting element is the second element of the list, considering the first element or the left side already sorted. And the current variable holds the element that is to be sorted. And what the inner loop do is it compares the current with the sorted part of the list. And if the current is smaller than any entry of the sorted part, then the sorted part will shift one to the right and it will create space where we can insert the current. And this is from where it is called insertion. Everything else is the same as the previous sorting algorithms. We're generating a random list of numbers, then we're inserting them into the input file, then we're calling the insertion sort method and just calculating the execution time as always. Afterwards, we're writing the output into the insertion sort file, and that's it. And we're displaying the execution time on the screen. So let's go and test this out in all three languages. JavaScript, to run this insertion sort algorithm, it only took 68 milliseconds, which is quite slow. As for Python, it took it 3,315 milliseconds to execute this algorithm. And to execute this algorithm in C++, it took 79 milliseconds of execution time. So that's it for insertion sort. Now let's move to the next one. Time to set up the game with quicksort. Fast and efficient divide and conquer algorithm. It's like throwing a party where guests rearrange themselves around a chosen pivot until everyone is in the right spot. It was hard to understand this. Don't worry, let's go and view the code and try to understand the code. Alright, so we've gone through this a lot of times in the previous algorithms, so I'm not going to explain everything. I'm just going to explain the method which actually performs the quick sorting. We're going to pick up the pace now. As you can see, the quicksort method is taking an array as an argument. So if the length of the array is less than or equal to 1, that means that the array is already sorted, because you can't sort only one entry, right? And next up, we will choose the pivot, and then we will create the left and right empty arrays. So here we're choosing the pivot, which is going to be only one entry. This 0 does not mean that it is the value of the pivot. It is actually the position at which it will store the value of the pivot in the array. Now, in the loop, what it does is it will start from 1 and go to the length of array, which is going to be 10,000 in our case. It will check if the element that it is traversing right now is less than the pivot, then it will push it into the left side, because everything on the left of the pivot should be smaller than the pivot, and everything on the right side of the pivot should be larger than the pivot. In quicksort, we divide the whole list into two parts and then we sort them accordingly. This is a quick way to do it. This is why it is called divided rule. And if the current element is greater than the pivot, then it will push it to the right array. Now this will happen n times until all the elements are sorted. Once this is done, we're returning the quicksort's left side dot. We're going to concatenate the pivot in between and the right side. I hope you're familiar with the rest of the code, so I'm not going to explain everything. Let's jump right into execution and compare the execution of all three languages. As you can see, for JavaScript, it only took 45 milliseconds, which is really fast. As for Python, it took 23 milliseconds of execution time to execute this algorithm. And for C++, it took 65 milliseconds of execution time. That's how simple quicksort is. Now let's pick up the pace and jump to our next algorithm. On number 5, we have merge sort. Merge sort is all about dividing and conquering too, but with a different approach. It breaks down the unsorted list into n sublists, each containing one element, and then gradually merges them back together. Let's dive right into the code and try to make sense out of this. So for merge sort, we'll be using two functions. The main function will be the merge sort, in which we'll be checking whether the array is more than 1, because if it's 1, we don't have to sort it. Then this will recursively divide the array into subparts. Then it will call the second method, which is merge. Now what merge does is merge creates a result array and a right and left index. Now it will check whether the left index in the left array is less than the right index in the right array. It sounds pretty cumbersome. But what it actually does is it is comparing in the sublist which one is the smaller and which one is the greater one. And then it will swap them. That's it. That's how simple it is. But yes, I know, I totally agree that this sounds really cumbersome. And afterwards, once everything is done, it will concatenate the left and the right side, and then it will merge it back. That's why it is called merge sort. It divides and then it merges it back once everything is sorted. And the rest of the code is the same as always. We're going to write the output in a file and we're going to show the result on the screen. So let's go and compare the execution time for all three languages. For JavaScript, it only took 18 milliseconds to execute this piece of code. As for Python, it took 25 milliseconds to execute this code. As for C++, it took 78 milliseconds to execute this piece of code. And that's it for merge sort. Now let's jump to our next sorting algorithm on the list. On number 6, we have counting sort. Counting sort is handy when dealing with a limited range of integer keys. Instead of comparing elements, it counts the number of occurrences of each element and uses that information to reconstruct a sorted sequence. So here in the code, as you can see, in the counting sort method, there is this max variable which is taking the maximum value of the array, and then it is creating a new array, count array, which is going to be of size max plus 1, and all the entries of this count array is going to be set to 0 initially. Then we have a sorted array which is empty as of now with no limits to its size. Now what we're going to do is we're going to count the occurrences for each element, and using the cumulative sum of these occurrences, we're going to reconstruct the sorted array, where we're going to push the index into the sorted array, and then we're going to return the sorted array. This is as simple as counting, and the rest of the code is same as always, and at the end we're going to show the execution time for this algorithm. So let's jump right into it and compare the execution time of all three languages. For JavaScript, it only took 6 milliseconds to execute this algorithm. As for Python, it took 29 milliseconds to execute this algorithm, and it took a hefty sum of 71 milliseconds to execute this algorithm in C++. And that's counting sort for you. Now let's jump to our next algorithm. On number 7, we have Radix Sort. Radix Sort is particularly interesting because it works with integer keys by considering each digit at a time. It's like sorting numbers based on their individual digits, starting from the least significant to the most significant. As you can see on the screen, the Radix Sort algorithm basically uses a stable sorting algorithm like counting sort to repeatedly sort the numbers based on their value. What it will do is it will check for the maximum value in the list, then it will divide it by one exponent, and then it will round off the whole value using math.floor. If the value greater than 0, then it will perform the counting sort on it, and then it will multiply the exponent by 10. Afterwards, it will return the array, and this same process keeps on happening until the whole array is sorted. As I mentioned before, this uses the counting sort, so the counting sort function is a must to be defined. The rest of the code is the same as always. At the end, we're going to compare the execution time for all three languages. So let's go and do that. It only took 16 milliseconds to execute this piece of code for JavaScript. As for Python, it took 23 milliseconds to execute this algorithm. It took 107 milliseconds to execute this piece of code in C++. So that's Radix Sort for you. Let's jump on to the next algorithm on our list. On number 8 in the list, we have Bucket Sort. Bucket sort is all about distributing elements into buckets and then sorting each bucket individually. It's like dividing the problem into smaller, more manageable pieces and solving them one at a time. So let's look at the code. As you can see on the screen, Bucket Sort has 4 major parts. The first one is going to be the initialization of the size of the array, the buckets, and the sorted array. The second part is going to create buckets of size n into the array's ith index. And the third part is about sorting the individual buckets one by one. In this, we're going to traverse throughout the bucket and sort it out. Once all the buckets are individually sorted, the fourth part concatenates the sorted buckets into the sorted array, and at the end, the sorted array is returned. The rest of the code is same as always, and at the end we are displaying the execution time same as always. So let's jump right into it, how much time it took for Python, C++, and JavaScript to run this algorithm. For JavaScript, it took 24 milliseconds of execution time. As for Python, it took 29 milliseconds of execution time. And as for C++, it took 94 milliseconds to execute this particular algorithm. So that's bucket sort for you. Now let's jump to our second last sorting algorithm. Number 9, we have comp sort. Comp sort is a variant of bubble sort with a more advanced mechanism for comparing and swapping elements. It's like giving bubble sort a sleek upgrade for better performance. In the code on your screen, as you can see, in the comp sort function, firstly we're declaring m as the size of the array, then we're declaring gap, which is actually equal to the size of the array, and then we are assigning true to the flag swap. Now, what happens in comp sort is comp sort compares the current element and gap plus the current element. And if they're out of order, it will swap them and then set the swap flag to true. And afterwards, it will shrink the gap by a factor, which is 1.3 usually, and reassign gap a new value. So this process keeps on repeating unless there's no swapping in a pass. After everything is sorted, the function returns an array. So let's go and run this out, check the output and the execution time for all three languages. For JavaScript, it took 12 milliseconds of execution time to run this algorithm. As for Python, it took 36 milliseconds of execution time. As for C++, it took 75 milliseconds of execution time. As for the input file, all the entries are disorganized. In the output file, all the entries are sorted in the right order. And that was comp sort for you. So now let's move to the finale of our video today, our 10th sorting algorithm. On number 10, we have shell sort. Let's talk about shell sort, an algorithm that starts by sorting elements that are far apart from each other and gradually reduces the gap. It's like breaking down a big problem into smaller, more manageable pieces. As you can see on the screen, what shell sort does, it creates a gap between two elements. The gap is larger at the start, and as time goes by, the gap decreases to a point where the gap is minimum to 1, and that is where the last sorting is done. Once the sorting is done, it returns an array, and that's it. That's how shell sort works. Let's go and compare the execution time for shell sort. It only took 11 milliseconds of execution time for JavaScript to run this algorithm, whereas it took 40 milliseconds for Python to execute this algorithm, while C++ took a hefty sum of 102 milliseconds of execution time to execute this algorithm. As you can see, the input file has the randomly organized entries, and the shellsort.txt file has the sorted output. There you have it, our journey through the top 10 sorting algorithms in JavaScript, Python, and C++. Sorting algorithms are the backbone of many applications, and understanding their strengths and weaknesses is a key to making informed choices as developers. If you enjoyed this video, don't forget to like, share, and subscribe for more coding adventures. Until next time, happy coding.